All right, folks, it's Bass Action back in action here. In this video, we're going to do a quick overview connecting the sine and the cosine graphs. And then in the next video, you're going to learn the details of how to actually create the graphs completely on your own. So the first thing that I want to call your attention to are these standard equations that I have up here at the top. And I want you to notice that the two equations for sine and cosine are the same equation. They have all the same elements, and we're just going to swap out the sine and the cosine. That means that all the parts are going to be exactly the same. So if you can just always think of sine and cosine together, that's going to make your learning easier. The next thing that I want to remind you is that these particular letters and Greek variables that are here are not so important, the specific ones. What matters is where they're located in the equation. Different textbooks are going to use different letters, but where they are will remain consistent in terms of how they behave. So much of this is going to relate to translations and transformations that we've done earlier in the year. It's just going to look a little bit more complicated. So the first thing that we want to notice is that if you have a value that is added or subtracted either on the front or the back end, so on the front or on the back end of the equation, that is going to be a vertical translation. It's going to take your entire graph and it's going to move it up or down by whatever value you see right there. The next number would be right here in the front. It's going to be directly in front of the cosine or the sine. It'll be multiplied here, and that is going to be our vertical stretch. And that number, the absolute value of it, will be the distance above and below what I call the center line. So our sine and our cosine graphs are going to have a center line to make it equal above and below, and you'll be able to find that line, and this number will be the amount above and below. Now, I am skipping over this plus right here. If these were minuses in front of these, it would create a reflection in the same way that we've done reflections over the x-axis on all of our other graphs that you've done up till this point. This period change, okay, that's going to be a number that's going to be written right inside here. Now, I've written this in a more complicated fashion, but oftentimes you'll see this entire amount actually multiplied out, and you'll see it as this omega. I'm just going to write it as a W here, this omega x minus this phi. Okay, so this omega, or the W, okay, is going to tell you whether or not the period on your sine or cosine graph has changed, okay? It's how long, the period is how long it takes for the graph to repeat. If this value is just a 1, then there is no period change. If there is a value in front of the x, or that's been factored out, then the period, the amount of time it takes to repeat, has been changed. And you would find that new value doing this calculation right here. The new period will be 2 pi, because this is our period for our parent function, divided by whatever value is there. That's why if it's a 1, it just stays 2 pi. The last thing is going to be the phase shift. Sometimes you'll see it in this factored amount, in which case you can just pull the phase shift simply by grabbing this value, this phi over the omega, and that'll tell you how much to shift the graph left or right. But remember from last semester, if it's in this already, multiplied out part where it hasn't been factored, then you cannot simply read this value as the phase shift. It has to be the phi divided by the omega. And again, in the next video, we're going to go through the exact steps for how to actually create one of these graphs all on your own. Now, we've already talked about and kind of started to familiarize ourselves with the parent graphs for sine and cosine. So I'm just going to jump right into these little graphs, and this will connect to what we just had up above. Amplitude is going to be that coefficient, that amount above or below that center line. So when we look at this sine graph, you can see that there's this imaginary line, in this case it's the x-axis, that is creating a nice even amount division of the top and the bottom, okay? So the amplitude on the parent graph is a 1. The period, that's how long it takes for the graph to repeat. So we've seen this before. We could pull out, let's say, this chunk right here, And we can see that that means that it takes 2 pi for the graph to start over. Domain, we've already practiced this, negative infinity to positive infinity, because of course there's arrows on the ends of these graphs. And the range, that's our how low and how high, and that's going to be our -1 to 1. Now, on our cosine graph, of course, we've seen this before as well. On the cosine graph, all these values are going to be the same. Amplitude is still 1. The period is 2 pi. The domain is the same. The range is the same. So this remains consistent between sine and cosine. Our cosine graph, if we wanted to grab a full picture of the behavior, all parts of the graph before it starts to repeat, that's what that one would look like. Now, down here at the bottom, you're going to make a little speculation here, a little conjecture, and then when the video is done, you'll answer the questions at the end, and then you can pop over to Desmos and actually enter it and see if your guesses are correct. Okay, so what I want you to notice about these graphs is that that sine and cosine, because they are these same equations, are actually phase shifts of each other. So if you could pick up this sine graph and move it left or right, we could orient it so it would actually, this cosine graph, we could orient it so it would look like a sine graph, or vice versa. We could pick up this sine graph and shift it left or right and turn it into a cosine graph. So the more you can start to get comfortable with that idea, the better. So what I want you to do is, when this is done, I want you to pop over to Desmos and first verify to yourself that if you enter in these two equations right here, that they will actually be the exact same graph. So the parent sine graph is the same as a cosine graph with a phase shift of pi over 2. And I can just read it because there's no period change. Then what we want to do is we want to think about, if we entered this equation into Desmos, it's not quite going to match because you can see that the phase shifts are in different directions. So how could we modify this equation here so that it would turn into these same graphs right here? And you can make yourself a little bit of a guess and see what it is, and then go play with those numbers in Desmos and verify it. I also want you to play with the cosine graph versus the sine. So now we're going to look at our cosine graph and notice that its phase shift, it would be to the left because that's a plus, of pi over 2 would get these two to match. If you enter those two into Desmos, you'll get the exact same equation. Then we're going to enter this one in. Notice again, the phase shifts are in opposite directions. What could we do to this equation so that it becomes the same as one of these? Okay, so what other change could we do so the equation will be different but would create the same graph?